Although we usually recommend studying both specificity and sensitivity separately, very often it is useful to have a one-number summary, for example, for optimizing purposes. One metric that is preferred over overall accuracy is the average of specificity and sensitivity, referred to as balanced accuracy. Because specificity and sensitivity are rates, it's more appropriate to compute the harmonic average. In fact, the F1 score, a widely used one-number summary, is the harmonic average of precision and recall. Because it is easier to write, you often see the harmonic average written like this when defining F1. It's important to know that depending on the context, some types of errors are more costly than others. For example, in the case of plane safety, it is much more important to maximize sensitivity over specificity. Failing to predict a plane that will malfunction before it crashes is much more costly error than grounding a plane when in fact the plane is in perfect condition. In a capital murder criminal case, the opposite is true, since a false positive can lead to executing an innocent person. The F1 score can be adapted to weigh specificity and sensitivity differently. To do this, we define a constant, we'll call it beta, to represent how much more important sensitivity is compared to specificity. And then we can consider a weighted harmonic average like this. The F underscore MEAS function in the caret package computes this summary with the beta defaulting to 1, but you can change it to other values. All right, so let's rebuild our prediction algorithm, but this time maximizing the F score instead of overall accuracy. We can write this code. And now, instead of plotting accuracy versus the cutoffs, we'll plot the F1 measure against the cutoffs. We see that F1 is maximized at a value of 65%. And this maximum is achieved when we use the following cutoff. It's 66. A cutoff of 66 makes more sense than 64. Furthermore, it balances specificity and sensitivity of our confusion matrix. You can see that by typing this. We now see that we do much better than guessing, and that both sensitivity and specificity are relatively high. So we can say that we have built our first machine learning algorithm. It takes height as a predictor and predicts female if you're 66 inches or shorter.